Hi everyone, welcome to Math Tutorials 82, where we master together the skills that will set you up for success. So today we're going to be talking about the equation of a line. And so you might be asking yourself, well, why is that important? Simple. One, we use it in our everyday lives for basically just about everything. So construction, such as roads, highways, they all follow a straight line. Your buildings and structures, even those sidewalks, etc., all come from a straight line. So you might be asking yourself, so what is a straight line exactly? Well, it follows this equation, which is basically y equals mx plus b. So what is this? So y is the function, results, m is the slope of the line, x is the value of the point at that x-axis point, that x-axis point, and b is the y-intercept. Or if x equals 0, the point on y where the line will intercept the y-axis. This will become a whole lot more apparent in a little bit. So, as I mentioned, it's important to know this because this is something that we'll see in our everyday lives in all ways, shapes, and forms. So, you might be asking yourself, so how do we calculate the slope? Simple. So our slope is basically taking 2 points in our line and just subtracting point 1 from point 2, which I will show in a little bit with our demonstration. So to make it more clear, so the demonstration will be y equals x squared. So we'll do the demonstration for y equals x squared. Since this isn't a line, we can't really do the generic equation, which you have slope equals 0.1 minus 0.2. Rather, we have to do something else. So we have to do a derivative. So dy dx equals 2x. And so let's graph this out for the x-axis and the y-axis. So for 0 it's 0, for 1 it's 1, for 2 it's 4, for -1 it's 1, -2 it's 4. So it's a parabola that's going upwards. So we're going to find the slope for these 5 points. So in this case, this becomes 2x. So for FA, that equals 2 times -2, that equals -4. So the slope right here is -4. For B, that would be -2. So right here it's -2. For C, that would be 0. So For D, that would be 2. And lastly, for E, that would be 4. So we can only use this equation right here for a line. So let's do a typical line. So let's say we have a line that goes through 1, and at 1 and 2, 1 and 2, it goes through 1, 1, and 2 as such. So we'll take point A and point B. So M equals 2 minus 1 over 2 minus 1, that equals 1. So the slope right here would be equal to 1. And we can do this because it's a line. So a line will always have the same slope, but a higher degree function, just like y equals x squared, won't have the same slope at every point. So if you've watched thus far, you get 1 gold star. So now that we saw that a line has a constant slope, but a function of a higher order does not necessarily have the same slope throughout. So now we had a x-axis that went between -2 to 2. So the question now is, what would the value of y be if we used -2 to the 1/2? This is an imaginary number, so we won't deal into it, but I'll leave it up for you to think about. And this would be for this function that we just did the demonstration on. So equals x. And in this case, since the slope is 1, it's just y equals x. So the line goes like this. So it has a full slope of 1, but it intercepts at 0. So if we were to raise b to 1, our line will go up 1, and so on. So if we raise it to 2, our y-intercept is now 2. And if we were to go to -1, the line goes down to -1. And -2, it goes down to -2. So let's leave it at 0 just to see what happens with our slope. So right now our maximum and minimum points are -4 and 4. So let's see what happens when we double the slope. Now our maximum and minimum are -8 and 8. So they've doubled. So what happens when we do a negative? So let's do -1. The line reverses. So instead of having a minimum maximum of -4 to 4, now we have from 4 to -4, since it took a different direction. And the same thing, as the slope becomes more negative, we go from 8 to -8. So let's leave that at 1 for now. So going back to our demonstration, y equals x squared. So what happens when we change our slope? Well, in this case, we're going to leave our slope as 1, since, as you know, this is no longer a line, it's a parabola. So what happens as we change our x? So right now we're going from 16 to 16, and it has a minimum of 0, and we go from -4 to 4. So let's see what happens. If we add 1 to x, so instead of being y equals x squared, it becomes yx plus 1 squared in this case. we now have a maximum of 25, and it doesn't go through the 0 anymore. The entire equation went to the left by 1. And if we do a negative number, it goes to the right by 1. And now our negative 4, we hit 25. So what happens as we get more negative? The entire equation shifts more towards the right. And the same thing if we go positive, it'll shift more towards the left. So instead of having that minimum at 0 when x is 0, it either shifts to the left or to the right. So in this case, if we leave it as such, it will have its minimum at 0. So let's look at another example. So y equals x cubed. So slope is 1 and intercept is 0. In this case, let's just play around with x. So just like in the other case, so if we were to add a 1, let's see what happens. Right now it has a intercept of 0, and it has a minimum and maximum of 60 and minus 60. So what happens when we add 1 to x? The intercept stays at 0, but look at what's happening to our maximum and minimum. It doubled here and it doubled. Instead of being 60, like we saw before, it's 120. So what happens if we can continue going up? It almost triples. Same thing when we go negative. It almost doubles in negativity, because before it was negative 60 and now it's negative 120. And same thing when we keep on going more negative. It almost triples in the negativity. And so this just comes to show that this is something to expect from equations. So let's put it back the way it was. So something for you all to think about is, what would happen if we actually had a y-intercept, if we were to, increase it, decrease it, if there's any change? Well, I'll leave that up to you to think about it. So I hope you liked the video, and I'll see you in the next one.